Hello everyone, I am Somran. Welcome to the channel. So today we'll be discussing some quick revision of soil mechanics based on GATE and ESE. So we'll be starting today with the first chapter, that is soil properties. So we'll be starting with the formulas. So let's get started. So first formula, that is void ratio E is equal to volume of void by volume of solids. Then porosity N is equal to volume of void by total volume. Then E is equal to N by 1 minus N. N is equal to E by 1 plus E. Degree of saturation S is equal to volume of water by volume of void multiplied by 100. Then air content is equal to volume of air by volume of void multiplied by 100. So S plus AC is equal to 1, AC is equals to 1 minus S. Now percentage air void Na is equal to volume of air by total volume multiplied by 100. Then water content small w is equals to weight of water by weight of dry solids multiplied by 100. This can be written as weight W2 minus WD by WD multiplied by 100, that is total weight minus weight of dry solids. Then this water content can be determined by oven drying method, sand bath method, calcium carbide method, and pycnometer method. So in pycnometer method, this water content can be determined by, if this is W1, that is weight of pycnometer, then W2 weight of this moist soil with pycnometer, this is W3, that is soil rest of water with pycnometer, and W4, that is water with pycnometer. Then small w, that is weight water content, that can be determined as W2 minus W1 by W3 minus W4 into G minus 1 by G multiplied by 100, minus 1 multiplied by 100. So this is water content, and from here G, that is specific gravity, can be determined as W2 minus W1 divided by W4 minus W1 minus W3 minus W2. Now unit weight, that means gamma. So gamma is total weight by total volume of soil. Then gamma sat, that is W sat by volume V. Then gamma dash is equals to W submerged by volume. Gamma D is equal to weight of dry solids by total volume, and gamma S is weight of dry solids, or WD, that can be written by divided by VS or VD. Now unit weight can be determined by sand replacement method, submerged mass density method, core cutter method. So from here we after that G, that is true specific gravity, this can be written as gamma S by gamma W at 27 degrees centigrade. Now apparent specific gravity, that is GM, that is apparent specific gravity. So this is equals to gamma by gamma W. This gamma depends on soil condition, that is if saturated condition, then gamma is equal to gamma sat. If submerged condition, then gamma is equal to gamma dash. Now after this, the empirical formula, that is ES is equal to WG, gamma is equal to G plus AC into gamma W by 1 plus E. Gamma sat is equal to, this S will be 1, that means gamma W multiplied by G plus E by 1 plus E. Then gamma dash is equals to G minus 1 into gamma W by 1 plus E. Then gamma D, that is dry unit weight, that is G gamma W by 1 plus E, and gamma D is equal to total unit weight or bulk unit weight divided by 1 plus W, that is water content. Now from here we can see gamma D is equals to W by V, that is equals to G gamma W by 1 plus E. That means gamma D is inversely proportional to volume and inversely proportional to 1 by 1 plus E. That means gamma D is 1 by gamma D2, that is equal to V2 by V1, that is equals to 1 plus E2 by 1 plus E1. This is an important relation. Now we'll be starting with relative density, that is ID in percentage, that can be written as E max minus E by E max minus E min. That is, at E max means at loosest state and E min means at densest state. So generally E max can be written as 0.91 and E min, that is in densest state, that is 0.35. Now after this can be written in terms of dry unit weight, that is 1 by gamma d mean by 1 by gamma d whole divided by 1 by gamma d mean minus 1 by gamma d max. This can be written as in terms of volume, that is V max minus V by V max minus V min. Now coming to relative compaction, that is RC, this can be written as gamma d by gamma d max multiplied by 100, or RC and ID can be correlated as RC is equals to 80 plus 0.2 ID percentage. Now after this we will start with Stokes law, that is sedimentation analysis. So in Stokes law, terminal velocity Vs or settling velocity Vs is gamma w by 18 mu into g minus 1 into t square. So at t is equals to 20 degrees centigrade, these Vs can be written as 0.9 d square, where d is in millimeter and Vs in meter per second. And similarly at t equals to 27 degrees centigrade, these Vs can be written as 1.07 d square, and the units are same. Now after settling velocity, we will start with hydrometer method for sedimentation analysis. Now if hydrometer reading is RH, then this RH can be written as G minus 1 multiplied by 1000, as G is equal to rho by rho W, and rho W is equal to 1 gram per cc. So G can be written as also rho, and then RH is equal to rho minus 1 into 1000. Now there are some correction needed for hydrometer method. So what are the correction? Number 1, meniscus correction. Number 2, temperature correction. And number 3, dispersion agent correction. So if I denote this at cm, this is ct, this is cd. So for meniscus correction, say this is a hydrometer and these are the readings, and if this is the higher meniscus, this is the lower meniscus, so we find this as RH, but the actual meniscus should be taken here, that is RHC, that is corrected hydrometer reading. So this will be the correction cm, as this is going in greater value, so this cm will be always positive. And temperature correction CT can be positive or negative, because if temperature is greater than 27 degrees centigrade, the density decreases, so CT becomes positive, and if T less than 27 degrees centigrade, density increases and CT becomes negative. And similarly, this dispersing agent correction is always negative, as after mixing of this dispersing agent with the soil, the density increases, so the CD value becomes negative. So the corrected hydrometer reading can be written as RH plus Cm plus minus Ct minus Cd. Now after this correction, we will start with the effective size of soil, that is effective diameter. Now in effective diameter, we can find D10 as the effective diameter. So starting with D10, that is effective size of soil, we'll start with Cu, that is coefficient of uniformity, that is d60 by d10, then coefficient of curvature, that is d30 square by d60 by multiplied by d10. Now if Cu greater than 4, then it can be well graded gravel. If Cu greater than 6, then well graded sand, and this Cc value lies 1 to 3, and if Cc is less than 1 or Cc is more than 3, then this is poorly graded soil. After this, we will start with the consistency curve. So consistency curve means, here this is water content and this is volume. So this curve remains like this. So this is liquid limit, this is plastic limit, this is shrinkage limit. So this is liquid state, this is plastic state, this is semi-solid state, and this is solid state. So corresponding to this is Vd, corresponding to plastic limit this is Bp, and corresponding to this liquid limit this is Vl. Now from this we'll see the value of Ip, that is plasticity index. So plasticity index, that means Wl minus Wp, liquid limit minus plasticity limit. So more Ip, more will be the plasticity. Now after this, shrinkage limit Ws, this can be determined by this formula, that is G is equal to 1 divided by gamma W by gamma D minus Ws. This Ws is the shrinkage limit. After this, we can also write Ws is equal to E by G. After this, we will start shrinkage ratio, SR. So shrinkage ratio, that can be defined as R is equal to V1 minus V2 by Vd multiplied by 100 whole divided by W1 minus W2. Now at shrinkage limit state, we can write R is equal to V1 minus Vd by Vd multiplied by 100 divided by W1 minus Ws. So this formula can also be written as, this R can be written as gamma D by gamma W. So this formula can be written as 1 divided by 1 by R minus Ws. After this, from this shrinkage ratio formula, we can remember the volumetric shrinkage. So the volumetric shrinkage will be equal to volumetric shrinkage, that is Vs, can be written as shrinkage ratio multiplied by W1 minus Ws, or volumetric shrinkage is equal to V1 minus Vd by Vd multiplied by 100. But at liquid limit, volumetric shrinkage can be written as shrinkage ratio multiplied by Wl minus Ws, and at plastic limit, Vs can be written as shrinkage ratio multiplied by Wp minus Ws. Now after this, we'll start consistency index, that is IC. Now IC can be written as Wl minus W divided by Ip. So IC is nothing but directly proportional to the strength and inversely proportional to consistency, that is flow. And IL, that is liquidity index, that means W minus Wp by Ip. So Ip is directly proportional to consistency, that means inversely proportional to strength. That means more IC, so more will be the good will be the soil condition for foundation, and this is IL, so more the IL, so less will be the quality for soil for construction of any foundation. Now IC can be written as like this, that is, these are inversely proportional. After this we have IF, that is flow index. So flow index means this is flow curve. Say this is W1 required N1 number of blows for Cassandra test, and then W2 water content can be found by N2 number of blows. So this is in percentage and this is in logarithmic scale. So IF can be written as a slope, that is W1 minus W2 divided by log N2 by N1 base 10. So this is nothing but directly proportional to loss of shear strength. Now after this, IT, that is toughness index, can be written as IP by IF. So after this we can write IS, that is shrinkage index, that is WP minus WS. Lastly we have some things, that is sensitivity, that is unconfined compressive strength for undisturbed soil whole divided by QU for remolded soil. And one last thing, that is activity, that is AT is equal to IP divided by percentage of clay, that means percentage of particle size finer than 2 micron. So this is all about the quick revision of this first chapter. So in the next video we will start with some conceptual numerical problems. So hope you like this video. If you like this video, don't forget to hit the like button, and if you are new to this channel, don't forget to subscribe. Thank you for watching.